We've been looking at several methods for solving quadratics. Today I want to talk about when to use which method. So sometimes one method is a better choice than another. Graphing, the strength of it is it's easy if you have a graph. A weakness is that it rarely goes through integer values. So if it's between integers, you may not be able to see exactly where it crosses. Our graph over here is going by ones, so we can see it crosses at x equals -2 and at +1. This is a nice method to use if you are given a graph. This is not one we're going to focus on in the homework. We are going to spend some time on factoring. That's a good one to use. And this is probably one of my favorites because it's fast and easy. The weaknesses of this one is not everything is going to factor. So not every quadratic factors. When to use this is when you can find a product-sum relationship. And when we talk about not every quadratic factors, we're talking about it factoring over the reals, and specifically, probably mainly just integers, although the fractions aren't too bad if you have something like 3/2. That's not too bad to factor. Let's go ahead and look at this one. This does have a product-sum relationship. I need something that multiplies to 10. So it has a product of 10, and it has a sum of -7. And so those would be -2 and -5. So when you factor this, you'll have x minus 5. X minus 2 equals 0. So my solutions for this would be 5 and 2. Square root property is also a nice one. I think this one's also fast and easy. This only works, though, if you have two, and I'm going to put in quotes, terms. So if you have a squared term, so one term is squared, and the other is a constant. So I'm going to write that over here, when to use it. If you have two terms one that is squared and the other is a constant. So I might have, say, r squared equals 5. That would be a square root property, nice one. X minus 2, that quantity is squared, so I'm calling this a squared term. So I'm considering this one term. On this one, I can go ahead and take the square root of both sides. So x minus 2 equals plus or minus square root of 5. And then add 2 to both sides, so x equals 2 plus or minus the square root of 5. Our next method we've covered is complete the square. And this is an alternate to the quadratic formula. Completing the square is derived, the quadratic formula is derived from completing the square, so we would never have the quadratic formula if we hadn't completed the square for a quadratic. And I've included those notes in a document in Schoology if you are interested on seeing how the quadratic formula was derived from completing the square. That's optional though. This is an alternate to the quadratic formula, and its strength is it works best when your leading term is 1 and middle term even. So that's when I want to use it. Sometimes things won't factor, like this one doesn't factor, but it is a nice one to complete the square. It's kind of a pain, and I would consider that its weakness. And you'll want to use this method again when the leading coefficient is 1 and middle term, or your linear term, is even. So on this one, you create a space, and I'm going to move that 18 to the other side. So all your x's are on one side, numbers are on the other. Leave a little bit of space. You take half of your middle term and square it. So negative 2 squared, 20 squared is 4. I'm going to add that to both sides. This is now a perfect square trinomial. It's x minus 2 squared, and that's equal to negative 14. Take the square root of both sides. So plus or minus square root of negative 14. And then you get x by itself. I'm going to add 2. So this will be 2 plus or minus. I can take out the negative from the square root, and you'll get an I. There's no perfect square that goes into 14. So you'll just leave that 14 underneath your square root. Quadratic formula is going to work all the time, so that's what I would consider its strength. Weakness of it is it's longer than the rest of the methods. And I would use this when the leading coefficient is not 1 and other methods do not work. So if it doesn't factor, or if you don't have a squared term and a constant, so in this case I have that middle term, so I'm out of luck for the square root property. Complete the square, I have a leading coefficient that's not 1, and this middle term was not even, so complete the square is not a good choice. This one actually does factor. You can find something that multiplies to 6 and adds to -5. So I would probably split the middle on this one, but I'm going to go ahead and use quadratic formula so we get practice on a quadratic formula. In this case, my A is 2, B is -5, and C is 3. Let's go ahead and find the discriminant. So B squared minus 4AC. When you square a -5, you get positive 25. And that's minus 4 times A, which is 2, times C, which is 3. And that gives me 1. So this is going to be X equals the opposite of B, so positive 5, plus or minus the square root of our discriminant, which is 1. And that's all over 2 times A. So I get 5 plus or minus square root of 1 is 1. And so I'm going to have two solutions. I have 5 plus 1, which is 6, and that was over 4. And then my other solution is 5 minus 1, which is 4 over 4. And those both reduce. 6 over 4 reduces to 3/2. And 4 over 4 reduces to 1. So those would be my two solutions. That one does factor nicely, so I probably would have used factoring instead of quadratic formula, but I wanted to practice one with quadratic formula. This assignment, you'll be sorting your quadratics into these 4 methods: the factoring, square root property, complete the square, and quadratic formula. And then after you sort them, you're going to go ahead and solve them. You should have the same number in each group, and those directions are in the quadratic sort folder. And you can have as many attempts as you want. On part A, it won't let you go on to part B until you have a perfect sort. So you'll have to sort them correctly before it will let you do the next part. And then part B, I have it set up so you can have multiple tries on it if you want. So this completes our notes.